Hello, everyone. Welcome at our regular bi-weekly core protocol sync. We'll be talking about all of the major changes that have happened and some of the plans for the future. And Shamil is finally back with us, so he'll start this time.
Okay, sure. Last week I mostly focused on that root block importing PR. I finally made all these items. I did it, and among them are simple root block verification, some kind of request response protocols, pieces verification, checking by root block chain verification, and some kind of consensus for piece verification that receives last root block. I managed to pass several review iterations, and I believe I finished all the current comments. However, I encountered very strange behavior using our new async request response handlers. It's unexpected behavior, and I am still debugging it. Also, I was able to create this recent piece announcement cache. It is merged into the main branch, and I started with segment reconstruction. I added mm, I added a method to our archiver that allows reconstruct not blocks but pieces. It seems working. I need just to double check it. This week I plan to focus on finishing all my pending tasks, and probably I will start in my new task with changing our announcement mechanism to custom protocol. We are trying to move away from Kademlia because it seems that it's suboptimal, produce suboptimal results, which is unexpected because we wanted to the P2P worked as planned, but it doesn't seem so. So we will probably start to slowly move away from basic Kademlia. We will keep the main feature of DHT, like finding the closest peers to the key. This is the main feature of that. So we will use this feature and enable our own protocol and test how it goes. Probably we expect a little bit some improvements with our announcements. That's it.
Okay, any questions about this new functionality for Shamil? No. Okay, I think I can share my updates next, and there is quite a bit. So I'll be going through pull requests, and I guess feel free to interrupt me if something doesn't make sense. So I was quite happy to jump into the implementation of kind of preparation for consensus, but before that, uh, instead of that, I had to mostly work on the networking part to kind of sort of recover Gemini 3C. So there were some issues with the Kademlia, the way it worked. And basically, the root problem was that we needed to have like a confirmation that we have received the provider announcement and we have processed that and we are ready to process the next one. It wasn't actually possible before. So I had to implement kind of a way to pause a processing of a particular substream in Kademlia, but then turns out we have this limit of 32 substreams per connection. So we were immediately exceeding that limit. So we had to also add Kademlia reuse. However, it doesn't seem like either of those pull requests will land upstream. They do solve our problem, and that's why we are using our fork for now. But upstream, there will be different solution, but it is not clear at this moment when it will actually arrive. So that's what we have. This pull request basically imports the newest at that moment master branch of the Rust peer-to-peer plus those two pull requests on top. And that's what we are using. The rest of the changes are more or less just adaptation for new API in the master branch that has changed, and some minor changes to actually implement this reuse. And that reuse is basically We have a guard that we need to keep around for as long as we need, and once we drop it, we can read the next message. That's basically it. That's the whole API. Yeah, does the problem and solution make sense? I don't want to go through all of the lines in the code. Okay, if you're interested, you can go through pull requests. There are some discussions there. Okay, yeah, then the failed attempt to implement incremental record commitment. Basically, what we want to achieve is when we are doing archiving and we have several segment, we have some pieces in the segment. Initially, those are just records. We want to create commitments to those records as we are getting them. So basically, when we have the segment only partially filled, we already have some records essentially there, right? So we want to commit to those. And then as we have more data, we will commit to more. And then in the very end, we don't have to do work for the whole segment. We can just do the work for the very last record and we will be done. That way we can amortize the cost of creating commitments, which will be expensive or more expensive rather in the future across the larger time frame. It was a little bit tricky to implement, but nothing like impossible. And for that reason, there was a new module, incremental record commitment, which was basically exposing a function that you can feed with the segment. You can tell whether that's a full segment or only partial one. You can parameterize record size, which is useful for testing. And then we basically have this like accumulator, which is incrementally filled with commitments over time. And then at the very end, we can extract, we can drain it, and we can get commitments. In our case, just hashes of individual records. And everything worked fine until it didn't. And the reason for that was the way scale codec works. So basically, the way our segment looks like, it contains a vector of segment items. And then when we encode it with scale codec, the encoding will start with the prefix, which is the compact length encoding in scale codec of the length of how many segment items we have, right? And depending on number of segment items, compact encoding can take 1, 2, or 4 bytes, or even more, I believe. What happened is on Gemini 3C, we had very small headers and we have really large segments. So we sometimes were exceeding, or like often we were exceeding 1 byte compact length encoding and switching to 2 byte. What it means is that we are starting creating our record commitments and we think that the compact length encoding will be 1 byte, and we are creating commitments for records, but at a later date, our compact length encoding becomes 2. So all of the records we've committed to are shifted by 1 byte. So it's no longer valid and it was problematic. So I had to revert it. And I already have pull request in review, which addresses that particular problem. This one, it will be a breaking consensus change. The basic idea here is we have a custom implementation of encoding and decoding in scale codec, where we simply do not encode the length at all. The idea is that we know the size of the record of the segment, so we don't actually need to encode the length. We can just start at the beginning. We can read one by one, as many of those segment items as we have, right? And in order to be able to have padding at the very end, we just have another enum variant for the segment item, which is just padding, and it will be encoded to 0 byte. So that's kind of the hack. And the changes are really minor, just to encoding and decoding implementations, and some minor tweaks to the implementation and some offsets in the tests. So here we see 1 byte difference that was length encoding, and then a bit later we have 2 byte difference because we've encoded two things, and so on. But overall, it's quite minor change, and that will allow us to reintroduce incremental archiving at a later date without having this problem. Also, this older pull request had to deal with the fact that the very first record will have this like length updated over time. So at the very end, we not only need to create commitment for the very last record, we only need to create commitment for the very first one, and it was like complicated logic handling that. in this case, the first record never changes. So you can just move in the forward direction and it's much easier. Does it make sense? All right. So that was this one. Let me check it. Um, yeah, this is related to the earlier peer-to-peer implementation. It was actually not quite correct. I was dropping this guard a little bit earlier than necessary. I had to actually move it further into here, and then I had to actually send it into the background task here and drop it within background task after the whole process was happening. Otherwise, we were still hitting the same limits, even though it was technically possible to support them. So that was just a hotfix. Yeah. Then something that Shamil mentioned, we basically have this abstraction that we've created for the request response protocols where we have a trait and that I'm not sure it is modified. Yeah, it's here. Generic request, which we can implement for any data structure. And it has a type parameter response. Basically, that's all you need. Something that can be encoded and something that can be decoded. And that way we can implement different kinds of protocols. The problem for that was that generic implementation for the handler for that generic protocol was expecting the function that actually handles the request to be synchronous. And in some cases, we do need to do asynchronous stuff. So we had to change that to instead return the future. And there were some related changes, and the handle request itself is asynchronous now. So again, quite minor change, but it required some minor refactoring across the whole basically code base where we use request responses. But if you ignore white spaces, changes are not so big. Yeah. Does this one make sense? Okay. Then there were basically a run across different issues, how to improve both performance and reliability of the networking on the DSN side. So here was interesting problem. We have this data structure which is called piece cache, where we are storing things that should be cached by the farmer. These are the pieces that are not plotted but just completely unencoded. We have just reserving a particular piece of disk space, and we are storing pieces within that disk space. And we sometimes need to check whether we have the piece or whether we should store the piece and so on. But we were not actually dropping the mutex before starting to announce it. So essentially, all of the processing was serialized by this announcement. And dropping this guard after doing all of the checks and storing the piece in the cache actually improved performance quite a bit. And I also noticed that since we don't have that hard 32 substreams limit anymore in Kademlia, I mean, we have it, but we do have stream reuse, and we also do some buffering. So we can actually create more things and they will just be buffered. So it was possible to increase the concurrency for the tasks for Kademlia and for other queries on the peer-to-peer side quite a bit. And that also improved performance a little bit. The rest are just formatting changes. I hope this also makes sense. It's quite simple. Thanks, Ivan, for doing all the reviews recently. This is just a revert of that pull request because it was problematic. I will reintroduce it later. Then there was a problem described in the issue here where basically we have some churn on the network, and some nodes will remember about peers which are no longer online. So when we request something to download, they will give us some addresses. We will try those addresses. We will hit an error like timeout or connection refuse or something like that. And we will try again and again and again. It's just a waste of time. So this pull request basically implements a mechanism to temporarily ban those addresses, so we don't even try to reach out to them. Like it will fail right away instantly, and we can try some actual useful addresses instead. And it also implements some exponential backoff, so we don't ban them forever, but we do retry from time to time. And there are some discussions here. Um, I'm not sure we need to go into the details, but yeah, that is the goal. Um, does this make sense? Any questions? Cool. I don't remember what this is. Yeah, some random stuff. Um, yeah, the biggest change here is it turns out we can actually increase this even more. So what I did instead, I have decreased the base numbers. So in this case, base was 30, now it's 25, and for the regular, it was 120, now it's 80. But we are boosting with every connections much higher. This allows us to achieve even higher throughput. We can do more stuff with the network inside, and this also improves performance quite a bit. The others are just like logging changes. Um, I thought it was problematic, but we are running for a few days these parameters, and it seems to be okay. So still needs to be. It's like a research kind of question. I think at some point we'll get to it to parameterize this properly, like what we can actually do and how we can actually do. Um, but this is kind of the best educated guess we have for now. Then turned out no one can actually join 3C, and it was interesting because it worked for me. And the reason turned out quite simple. When we are doing connections, we had this. It's not clear here. Basically, at the bottom we have an implementation of the wrapper transport. I think this is the transport that basically has this dial method. And in dial method, we are checking what kind of address we are dealing with. And if it's IPv4, we are checking that it is potentially global address. If it's not, we need to allow non-global addresses, which means like local hosts and stuff like that. If it's not allowed, which is the parameters we provide in the instructions, then it will just refuse to connect to that IP address. This is there are reasons. Some hosting providers like Hessner don't like when you try to reach out to private addresses over the public interface. They will ban your machine. So this is the parameter which is important. However, it was applied to the wrong level. So in particular, when you have a DNS address rather than IP address, what you get is an error. So it just refuses to connect to DNS names at all, which are the addresses we had in the Bootstrap configuration. So what we had to do instead, we had to just move this wrapper at the lower level. So we resolve DNS addresses into IP addresses first, and then we can deal with IP addresses at the lower level as usual. So that was the interesting discovery here. I hope it makes sense. Then there was a problem I was debugging. Basically, we had more or less 100% CPU usage, and it turned out that the network inside was actually using that CPU. But because we had um, select from features crate, we were basically switching on different things and driving multiple features in parallel, one of which was networking. And when networking was blocking, everything was blocking. So this pull request introduced a new abstraction, and that abstraction is this function that takes a feature and returns a feature, but it will create a thread with this name, and it will run feature there. The only difference, rather than like using something like Tokyo's blocking, spawn blocking, or something like that, it will not only create that thread, it will allow some interaction with it. So if you drop the result, like you don't await on this, it will stop the background thread or like background feature in that thread. And equally, when that thread resolves, you will get the result here of the same type you expect. So it's kind of two-way interaction. Usually, when you have a blocking task, you cannot really interrupt it. And even when you have just Tokyo spawn, you will get a join handle that you can call either cancel or abort on it, but it will not abort immediately. This one will block until that background thing is dropped, which allows us to be certain that if we are doing some networking stuff, networking instance will be dropped when this goes out of scope. And then we are using this in our farm. so we can have both networking and farming plotting implementation in separate threads, and we are running them as before, but they're represented by different threads, which allows us to still farm when networking is kind of dead. Um, Hopefully, it doesn't happen, but it allowed us to debug better, and we clearly see in the task manager that the networking thread is using CPU. And this is re-exported, so Ivan, you can actually use it from the outside because it's like a useful primitive. I'm not sure where.
Yeah.
It is
So
re-exported somewhere.
I see that you're using a OS thread, right? Why not use the Tokyo spawn blocking API for that?
The reason is I cannot create a name for Tokyo's API, and I really want to have in Task Manager like HTOP you open, you see networking, you see farming and stuff like that. In Tokyo, it will just inherit name from the parent thread.
I think it should create, no? I think there is like some task builder or something, like very structured.
Maybe.
Which, yeah, I mean, we can test that. But anyway, they have some like Tokyo Top or something, like application which you can use, and which you can like using that you can like inspect different tasks and their usage, something like
Right.
that.
But that's like for asynchronous tasks. This is a blocking task anyway. So whether you're using thread pool from Tokyo or you create a thread separately doesn't really matter much. It's like created once and basically for the life of the application.
Okay, I think it doesn't create a thread, no, or it does for spawn blocking.
For blocking, it will create a thread, or it will take one from the thread pool. I don't remember.
Okay, yeah, makes sense.
Either way, it's more or less equivalent to this one. I just know that you can create a thread name, but we can switch to another one if necessary. Okay, then I was still having 100% CPU usage, and I was kind of confused why it's happening. And I found more or less 4 problems with the one of the implementations we have in the code base. The gist of it is the like where CPU usage was happening. We had a little bit problematic binary heap implementation. It doesn't have any, or like didn't have any handling of duplicates, and we were sometimes inserting several things and then deleting them one by one, but the rest of the application was basically assuming that there is just one instance of something. So there were a lot of assumptions mismatches, and in some cases we were deleting things which are not there, and it seems like a pathological case for binary heap. It just like uses a lot of CPU, and we have like hundreds like 600,000 keys in there. So it was using quite a bit of CPU when things were deleted. And this pull request basically fixes some of those problems. They are described here. I don't think I want to go into too much detail here. We had quite a discussion with Shamil about this as well. But basically, as far as I know, issues are fixed. We even found one more optimization we can do for with the caching. But at this point, I don't see networking thread in the task manager at all. So it uses like 1 or less than 1% of one single core CPU. So it's basically non-existent. Previously, it was using 100% CPU. So kind of an improvement. We can say 100x. And then there was a problem that users had where they didn't know whether they produced a block or someone else produced a block, and we didn't really expose the public key that was generated internally in the farmer. So this pull request changes some of the logs basically, and in particular, when we start the plot instance, we will actually print farm info unless you disable it to the screen, and some other things. So it is a little bit nicer, and you have better understanding of what is happening with the application. And printed at least on info. Is that? And today I had fun with Windows again. I decided to upgrade Substrate because there were a few things that were happening upstream. I don't know why it doesn't want to load. Okay. So basically, there is one pull request that was necessary for Ning. He was working on benchmarks, and there is a new microsystem for benchmarks, which is much better than the old one. So we wanted that, and then I noticed that just after I created this pull request, Lucian finally upstreamed his pull request, which supports subscription for all of the imported blocks, not just the canonical chain ones. And then I had to add that one. And there is actually a new feature which is called storage monitor. This was a long-standing problem in Substrate where you can run a node for a while, you run out of disk space, it crashes and it destroys the database. It is not recoverable. So what they wrote like a timer, which every 5 seconds or something like that will check whether you have at least 1 GB of free space. And if it's not, it will gracefully shut down itself. So it will not basically destroy its own database irrecoverably. However, this thing doesn't even compile on Windows. And because it doesn't compile on Windows, it's a problem. What is worse is that they have added this as a non-optional dependency to SC service, which basically means Substrate doesn't compile. Yeah, there is a pull request which fixes that, but it is not upstream yet, so we are kind of sort of waiting on it. If it doesn't move too fast, then we can probably just merge it into our fork. But it was created 3 days ago, and there were a few reviews just earlier today. So I'm hopeful that maybe tomorrow we'll be able to just merge master again, and it will be good. But otherwise, there were a lot of those trivial changes, just like last time, with the types, where they have changed the API from using block ID to block hash. Block ID is any num which can be either hash on block number, and they don't like block numbers in many places, so they want hashes explicitly. And that is the source of most of the changes. So yeah, that's pretty much all I've been doing implementation wise. There were a bunch of issues and discussions and reviews and everything, but code wise, this is kind of it. Any questions to me?
Are you ready to get started on consensus now? I think you worked through.
Yeah. So on consensus side, that incremental archiving preparation is something I need to do. After that, I will reintroduce incremental archiving. From there, we can do two things in parallel on the archiving side. We can change the commitment mechanism from hashing to KZGE, and then we can also do the erasure coding differently. So those kind of orthogonal, and we can do them in parallel. And after that, we will have hopefully primitive for ratio coding on the farmer side, so we can do the actual consensus on the plotting. And from there, we will be building the whole protocol.
Cool. There's a lot of work in the last couple of weeks.
Yeah, I'm kind of happy that we not only recovered Gemini 3C, like you can actually download the latest snapshot and it will actually supposedly work. It works relatively well. Like I almost don't see any networking errors. They happen sometimes, but very little. So great teamwork with everyone, fixing and testing and reporting and testing again.
Mine is working great, or was working great. I had to turn it off right now, but
Yeah, mine is also fine. Like apart from like general like slow syncing, I guess everything's good.
Yeah, I think there is still a lot of performance to be had, but we need to start somewhere.
that was I guess, an outstanding question I had is the sync speed is, as the chain hits 1 million, I mean, it's going to be very difficult to sync, but I assume there's improvements to be made there.
Yeah.
It's not even like syncing speed, is just that like blocking per speed. Yeah, it's
Yep.
kind of slow.
Yeah, I think we can do also a lot of things there. Right now, we are doing kind of the dumb approach, like we are going forward. I think we can do a lot more things. We can do some kind of snapshotting, and we can do, let's say, archiving in parallel, something like that. eventually we don't want to even start syncing from Genesis. We want to have some more efficient way to get there. Like there is a warp sync on the parity Polkadot side. Probably want something like that, but that is for the future.
Yeah.
We need to have basic version working first.
Yes.
All right. So that's it on my side. Rahul, what about you?
Yeah, so I revised the proposal block relay proposal last week after I talked to Nazar. My initial proposal required a change to substrate, and now after talking to Nazar, we decided to kind of work around it by using the gossip mechanism in substrate and the request relay mechanism. And I started working on the first change based on that roadmap that I put in the proposal. And I kind of got a approval from Nazar and Jeremy. But looks like today Jeremy came back with a bunch of questions, and looks like there are some conflict between what we decided and what Jeremiah wants. We may have to like resolve it maybe after the meeting, because I'm getting like very conflicting signals between what I discussed with Nazar and what Jeremiah would like. So hopefully after the meeting, let's try to figure it out. But apart from that, I was mostly working on getting the first change out, or at least doing the coding and trying to test it out. But now I'm going to put it on pause until I resolve these questions. Then I'll probably pick it up like later today after we get more clarity on that front. So that was mostly it. And yeah, I was going to also check with Daria. Last week, unfortunately, I was kind of busy with the block relay thing. I could not work on the primitives for consensus. If you need help, maybe we can sync up tomorrow or sometime and let me know how we can help. But yeah, that's it from me.
Do you think time after DevSync will be sufficient, or do we need like a longer call?
So DevSync is the next meeting, right?
Yeah, we have
Yeah.
usually like 30 minutes, and then we have some extra time after
Yeah,
that.
so we will need Jeremy also in the right. So we can do it after the DevSync meeting. Yes.
Okay, makes sense.
Okay.
Okay, Daria, you're next.
Yeah. Sorry, I got a little bit cold. I didn't want to cough in the microphone. I so have a couple of updates in the implementation side and in the research side. From the implementation side, there was this issue. There is this issue from Nazar that's created as an epic for the consensus implementation. I have created 2 more issues out of it. This was probably the one that your help, Rahul, would be most appreciated, is the connecting the Chia library actually functions that we need to create those tables. It's a C++ library, and I have tried create some bindings, but I have failed. I have outlined an idea of an API what it should be. We just need 3 functions basically to create a table, to query it for the proof, and to verify that proof. So this would be good if you could look at it. And the second issue that I'm more confident about, because I can actually run some prototypes, is the erasure coding based on fast Fourier transformation, and it can be used for both archiving and plotting, which is, I think, is a good thing. We can use the same function for both. So it lists the CKZG functions that will need to be used. It outlines the API, what can look on outside and what it's supposed to call, and it's in line with the spec. And I have also attached here an example that I wrote using somebody else's binding of CKZG. Basically what plotting should do with FFT and so on and so forth. I'm happy to write a better one or clarify it, but I hope it helps Nazar. Yep. And
Do I recall correctly that we don't no longer need arbitrary indices for the for the function on the plotting side?
So we have right now decided that we could go with 0, but some of our external researchers have concerns that they say that we may need points random, but we don't have a consensus on that yet. So right now we're just going with starting just regular one that's supported in all the libraries. And if we can actually devise a real concern for which we would need random points, they would introduce that back. Kind of, that hope that's a satisfiable answer. The one of those functions that recovers polynomials is present in CKZG, and it is not present in the other libraries that we've been using, either or ArcWorks or Dusk, which is one of the valid reasons why we need actually CKZG, because it allows recovery from a random set of evaluations, while in our previous implementation that we used in the prototype of 2.2, you could only convert basically between source points and parity points. You had to have either all source points or all parity points, which is not the case, we cannot work with
Not
that.
very useful.
Neither on archiving side nor in plotting. But this function allows us recovery from a random set of points as long as you have enough, which is great. Though we might need to fork it, but if somebody goes to implement it, I could give more details later. And it also has FFT erasure coding for commitments, which can be used on archiving side with fast for yes as well, which is great. And I think this should be all we should need. So that's on the implementation side. I have found also a tool called BindGen that can automatically create bindings to C libraries. And it worked quite well for CKZG on my computer. It did not work for Chia C++ library though, but we could discuss that in detail later.
Yeah, for sure, you probably need to write C interface first, and then you can create binding for that C interface, which is like two-step process. There is also CXX, I believe, which allows you to create, but I found it really problematic in many cases because it assumes you have all of the C++ code available to you. If you use some package manager or build tools like Mason or CMake, it gets complicated very quickly. It doesn't really want to work very well with those. So depending on how that Chia library is built, it might be helpful, not very helpful.
Yeah, so that's why I hope somebody with some more knowledge of it, like Rahul, I'm talking to you, can help us. Because I hope that my knowledge of C++ was enough, but apparently my knowledge is
I mean, if you
of
can
Rust is
write it in
probably
C++,
enough.
I can port C++ back to Rust if necessary. I just need an example somewhere with whatever API. Like I can write C
Okay.
API, I can write bindings for that on top.
Okay.
Like I even ported one project from one build tool to another build tool and then added C interface on top and then Rust on top and created Rust library out of it. So I have a
Oh,
little
then
bit
you
of
should be
experience with that,
fine.
but I need something that works so I can confirm that
Okay.
whatever I'm changing
Okay, I can
is
try.
making sense.
Or we should sync with Rahul. Maybe he's better with that. If you have time, let's just sync later. So that's on the implementation side. On the research side, we had a mini workshop with our external researchers last week. Did not devise any huge attacks. Did some modifications to calculations of pieces of segments and so on and so forth. Convinced them with that it fits well in our larger picture of blockchain with the C correlation and proof of time. They also had some networking questions, the caching of DSN, and I have pointed them to several write-ups. So that went great. And as a result of that, we have decided to move to the next stage, which is an official security audit and from several labs, and from supranational try to design a specialized ASIC for plotting. I just sent them all the materials and we'll see where that goes in the following weeks. That's all.
Finally, looks like finish line on that side of things. It's been under development for a very long time. Any questions on Darius updates? All right, Ivan, do you have anything to share this time?
No, I believe. Like I made a PR about like publishing some MISC stuff related to DSN, but apart from that, I guess no. Just following updates.
Okay. All right, I think those are all of the updates we have to share this time. I'm sure there will be much more next time, but for that we'll have to wait 2 weeks. So see you.